Okay, assignment 1, office hours. I'm going to go over the work for this. Now, these are the answers. So, you should have checked these already. Pause it if you need to. Now, the questions on the back, I did expect you to try. Some of them were a little more research driven. I'll talk about them, but you know, not necessarily things that'll be on your upcoming unit test. So, now all these problems are to be done without a calculator. So, we did some of these in class. I feel like it could be helpful to draw pictures of these. So -8, -15 would be over here, right? -8, -15. That would be the angle. That would be where it ends. And then we could construct the right triangle. So we need the hypotenuse, which we often refer to r is going to be square root of 64 plus 225, 15 squared, would be the square root of 289, which is actually 17. So that's the hypotenuse. Hypotenuse is always positive. So sine is opposite over hypotenuse. And cosine is adjacent over hypotenuse. So these should be negative. Tangent is, and that's not something you memorize, you just put on the picture. Tangent is opposite over adjacent. So that's going to turn out to be positive. So there's your answers. Okay. So I find drawing pictures of these is helpful. This is your X, this is your Y. Now you could try and memorize this stuff. I don't think it's worth it. Let me just draw a quick picture. So -3, 0 is over here. And that's one of those special triangles. So imagine that there is a triangle there, but it's collapsed on itself, which means that the opposite side is 0 and the adjacent and the hypotenuse is actually equal to the adjacent side because they're right on top of each other. So sine is going to be opposite 0 over hypotenuse, which is 0. Cosine is going to be adjacent over hypotenuse, which is going to give you -1. And tangent is going to be opposite over adjacent. So that's going to be 0. So there you go. Next one, -2, 2 would be over here. -2, 2. That's the angle that causes that. So then we could do, well, this is going to be square root of 4 plus 4 is 8. So it's going to be 2 root 2 for the hypotenuse. So sine is going to be adjacent, -2 over hypotenuse, which is going to be -√2 over 2. Cosine is going to be, sine is supposed to be opposite, so it should be positive. Cosine is adjacent, -2 over 2 root 2, which gives you -√2 over 2. And then tangent is opposite over adjacent, so that's going to be 2 over -2 equals -1. And then for 2 is right there, quadrant 1. Draw the triangle. So this is 4, this is 2. This is going to be the square root of 16 plus 4 is the square root of 20 is 2 root 5. So sine is going to be opposite over hypotenuse, which is 1 over root 5 or root 5 over 5. Cosine is going to be adjacent over hypotenuse. So it's 2 over root 5 or 2 root 5 over 5. For rationalize the denominator, tangent is opposite over adjacent, so that's 1/2. So should be good at that basic stuff. Next, I give you one trig and I want you to find the other. So what you should probably do is think, well, this is opposite over hypotenuse. and the hypotenuse has to be positive. So that means the opposite has to be positive. So sometimes, like if you did tangent and it was positive, it could be because they're both negative. That's a possibility, but hypotenuse is always positive. So you could draw a picture of like, well, where would the opposite side be positive? Here or here? And the hypotenuse is 5. So you could draw this. It's one of those. Now, they've gone ahead and narrowed it down for you. This is the one. So this is going to be the square root of 25 minus 1. So the square root of 24, which is going to be 2 root 6 for the adjacent side. So cosine theta is going to be adjacent to root 6 over hypotenuse. And it's got to be negative. Ooh, plus or minus. It's going to be negative because it's to the left. That could be an easy mistake. Next one, this is going to be adjacent over hypotenuse. And hypotenuse has to be positive. So that negative definitely belongs to the adjacent side. So where is the adjacent side negative? Well, that's over here, negative root 5. So it could be here or here. In both those situations, the adjacent side is negative. And they're going to tell you, well, we want quadrant 3. So we're going to get rid of that one. So we got to do Pythagorean theorem. This is going to be square root of 36 minus 5. So the square root of 31. And so then sine is going to be opposite square root of 31 over hypotenuse. And it should be, oh, it's this one down here, sorry. And down here it's going to be negative because it's going down. So it's going to be negative. And the hypotenuse is always positive. So there you go. So here, where sine and cosine negative, I would just be envisioning the sine graph and the cosine graph, or just sketch ones. And tangent and secant and cosecant, they all come from those things. So if you know these, you're good. So where is sine positive? Quadrants 1 and 2. Where is tangent positive? Well, that means where is sine over cosine positive, which means where are sine and cosine the same sign? Quadrant 1, they're both positive. Quadrant 3, they're both negative. So quadrant 1 and 3. Where's secant negative? Well, better question, I think, is where is cosine negative? Secant's one over co. It's a reciprocal trig function. It's always a co with a non-co. So cosecant or secant doesn't have co, so it's got to go with cosine. That's just the trick I remember. Where's cosine negative? Quadrants 2 and 3. Where is sine positive and cosine negative? Well, sine is positive in quadrants 1 and 2, and cosine is negative in quadrants 2 and 3. So where do they overlap? Quadrant 2. We did 11 together during the notes yesterday. Where's cosine positive? 1 and 4. Where's tangent negative? Sine over cosine. Well, that means when is sine positive and cosine negative, or sine negative and cosine positive? Where do they have opposite signs? Quadrant 2 and 4. So since it's or union, we just combine everything. They don't have to both be true. Okay, where's cosecant positive? Well, where's 1 over sine theta positive, which is where is sine positive? And that's quadrants 1 and 2. Where's cosine positive? Quadrants 1 and 4. It's and, so they both have to be true. So it's just quadrant 1 for the final answer. Where's cosecant? 1 over sine, negative, sine, negative. Quadrant 3 and 4. Sine, tangent, negative, sine over cosine, negative. Sine and cosine have opposite signs. Quadrant 2 and 4. The word is and, so the answer is where they overlap. 4. So, should be equivalent. Now, sine, cosine, tangent for the given problems. So, we've been given an angle, and we're trying to find the angle. We're trying to find sine, cosine, tangent. So, this is pretty much like problem 5 and 6, right? So cosine is adjacent over hypotenuse. So that means the negative definitely belongs to the adjacent side. So I'm going to draw a quick picture. Where is adjacent side going to be negative? It's got to be over here. Adjacent side is always left or right. So this is where it's negative, and the hypotenuse is positive. So it's either here or here. You got two possible answers. And if they didn't say anything, we would give both of them. We give this one, and we give that one. But they said quadrant 3 only, so just this one. So Pythagorean theorem, we're going to do 16 minus 1 square root of 15. And so then sine is opposite negative, by the way, because it's down, negative square root of 15 over 4. Cosine we already had. And tangent is opposite over adjacent. So that'd be positive 15. There you go. Draw little pictures. Secant. I'm not going to memorize secant. I'm going to say, oh, well, secant's 1 over cosine, right? And so that means it's same thing as cosine equals negative 3/5, and that's going to be adjacent over hypotenuse. So the picture is adjacent side is negative, so it's either here or here. Hypotenuse is 5. Pythagorean theorem. Now they said quadrant 2, so it's got to be this one, not this one. Pythagorean theorem says this is going to be the square root of 25 minus 9, which is the square root of 16, which is 4. It's going to be positive because it's up. So sine is opposite 4 over hypotenuse 5. Cosine is adjacent negative 3 over 5. And tangent is opposite over adjacent, so negative 4/3. There we go. Okay, next one, sine is opposite over hypotenuse. It's got to be positive. So where is the opposite side positive? Either here or here. Those are the places, right? Positive 2, positive 2. Hypotenuse is 3 and 3. We want quadrant. This is not quadrant 1. So this is the one we want. Pythagorean theorem is going to be 9 minus 4 is square root of 5. And it's going to be negative because it's to the left. Adjacent side is negative. So sine, we already know, is 2/3. Cosine is going to be adjacent negative root 5 over 3. And tangent is going to be opposite over adjacent negative 2 root 5 over 5. Okay, next one, cotangent is 1 over tangent, which means tangent equals negative 1 over 6, which is opposite over hypotenuse. Now, I don't know if the negative belongs to this or to this. It could be either one. So we have to entertain those are two possibilities. So the picture is going to be, well, where's the opposite side negative? Down here and here, negative 1, negative 1. But then so opposite over adjacent. But then the adjacent side has to be positive. So that would be here. So it's either this triangle or the opposite side is positive and the adjacent side is negative, which would be over here. So that one's out. So it's got to be one of these ones, either quadrant 2 or 4. And they want quadrant 2, so that's the one we got to go with. But I want you to keep entertaining that there's these multiple places for these answers. So this is going to be the square root of 37. So sine is opposite 1 over the square root of 37. So that's going to be square root of 37 over 37. Cosine is adjacent negative 6 over the square root of 37 equals negative 6 square root of 37 over 37. And tangent is opposite over adjacent. Usually you don't leave the negative in the denominator of a fraction. Put it in front, put it in top. Okay, last one's solving some trig equations here for special cases. So sine, kind of doing the same thing we're doing up here, but there's just weird situations. So this is opposite over hypotenuse. You think, well, where would the opposite side be positive? Either here or here, right? But then the adjacent side is the same length, which means that these end up lying right on top of each other. The way that happens is when it's right here. So theta equals 90 degrees, okay, plus 360K. That's the period of sine. So just in case, so you get 90 degrees. If you add the next one, it's be 450, too far. Subtract 360 from this, you get negative 270. Subtract another 360, you're at negative 630, too far. Okay? Cosine is adjacent over hypotenuse. So when could the adjacent side be 0? That'd be either be here or here, right? The adjacent side, or sorry, no, wrong place. Either here or here, because in the triangle, this side goes to 0, which means that the opposite side is the same as the hypotenuse. So it's either here or here. So theta equals 90 degrees plus 360, or theta equals 270 degrees plus 360, or you could summarize these both together and say theta equals 90 plus 180K, because that would give you all of them. Now, this is an interesting place on the cosine curve. Think of the cosine curve. It looks like this. When does it equal 0? Here and here, and it actually happens exactly half the period apart. That's the only value that happens for. So we get theta equals 90 to 70, negative 90, negative 270. Okay, tangent. I don't memorize tangent values. I think sine over cosine. So this is asking, sine is opposite over hypotenuse, right? And cosine is adjacent over hypotenuse. And so then it'd be like the hypotenuse cancel each other out and it's opposite over adjacent. So when does opposite and adjacent have the same length? Well, that would have to be like this, 1 and 1, or 1 and negative 1, or 1 and negative 1, or 1 and negative 1. Now, they got to both be the same sign. So it's either this one or it's this one. There's two possibilities. The angle that creates this, that's a 45-degree angle. So theta equals 45 degrees plus 180K. By the way, the period for tangent is 180K. So theta equals 45, 225, negative 135, negative 315. Those are all the answers between 360 and negative 360 and positive 360. All right. This one right here, cosine is adjacent over hypotenuse. Negative definitely has to be adjacent side. Hypotenuse is always positive. So when's the adjacent side negative? Over here. So it's either here or here. But the hypotenuse is 1. That means it collapses on itself. And the opposite side is 0. So I ignore the 3 for a second. I just write it here. I say, well, what angle would this be? 180 degrees plus... It's going to happen 360K later, full period later. Then we want to get the theta by itself. We divide everything by 3, including 360K. This is the way I'm going to start doing all my work this unit, setting up these all solution expressions and then getting what I need from it afterwards. I think that's the easiest way. So 60, 180, 300, negative 60, negative 180, negative 300. 6 answers. You need all of these. So there you go. That's all that detailed trig on the front. So the questions on the back, I'll talk about a little bit. What culture is usually credited with the discovery and invention of trigonometry? So you could have Googled that. And, you know, you might have found conflicting answers. Some of you guys might have got something different. So generally, it's the Egyptians. Now, a Greek guy was the first to made first trig table. So, but yeah, it's the Egyptians. 25, since most modern calculators can only do plus minus multiplication division, and that's true about like even computers. Take computer science, we'll talk about this idea that at its core process, computers are doing addition, subtraction, multiplication, division. That's it. And they do that for everything, calculations, graphics, whatever. Explain, or it says, how would they compute sine? So this is actually interesting. This is a Calc BC topic, and they use something called a Maclaurin series, which is a version of a power series. So there's some different things, and this is a Calc BC topic. But this is the expression for sine. This is how you can get an answer for sine with only addition, subtraction, multiplication, division. X minus x cubed over 3 factorial plus x to the 5th over 5 factorial minus dot 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 plus. So there's this pattern here, okay? And it goes, if you take all the infinite terms, it goes on for infinity, it gives you the exact answer. Now, realistically, we don't need exact answers, and that would take forever. So we say, let's take the first 5 terms. That's good enough for what we're doing, whatever it is. And this is where your calculators actually calculate sine. They don't memorize all the sine values. Create, describe any technique you can find to easily measure the height of the tallest object on campus. So, like, I don't know, the Clark Center or a big tree, palm tree or something. There's a bunch of different ways. Like you could wait, you could measure the shadow, you know, of a palm tree, right? And then measure your own shadow. And then what happens is this angle is the same for both of these. So you could put this in here, and you got similar triangles, right triangles. You could use similar triangles, right? Sides are proportional. So you know your height, and you know the length of your shadow, and you know the length of the Billy's shadow. It's hard to get the measuring tape of the tree though. So then you could find the height of the tree by doing this over this equals this over this, similar triangles. You could do another similar triangle thing where you could say, okay, well, I'm going to put a mirror on the ground, and I'm going to walk backwards until I can see the top of the tree in the mirror, and use those similar triangles. So it says shadows. You could do similar triangles that way, because if you flip this guy, it'll fit right in there. There's lots of different ways of estimating, measuring a tall object without actually having to measure it. Something that could help you do it quicker, especially if you didn't have measuring tape, is to do it in strides. And so you could find the average, you know, figure out the length of your strides, so then you could walk off different distances really quickly if you kind of know the length of your stride. So what you could do is you could take some known length, like in the math hall, from this end to this end. Here's our room. Yay. Right. It's about 199 feet from this edge, this corner, to the corner right here where the carpet ends. And you could just try and take average steps, count how many of them, right? So, like, I think it took me, like, I don't know, 78 strides. So then I'm going to do 199 divided by 78. So it's going to go in twice. It's going to be 156. Actually, I didn't need to borrow. So you got 43 left over, drop to 0. This will be another 5, decimal point, 350, 390. Drop that. We can do another 5, 390. Another 1. I don't know, it's probably pretty good. So 2.551 feet equals 1 stride. I can use that to help me calculate heights of tall objects. Create, describe any technique you can find. So you could look it up, Google it, or you could come up with your own idea to estimate the volume of General Sherman, which is a famous Civil War general, but we're not talking about him. We're talking about the biggest tree. It's a sequoia tree, it's the largest volume tree. They consider it the largest tree in the world, but there's different definitions of largest tree. There could be largest in terms of root structure, largest in terms of height, largest in terms of how far out the branches, but volume of the tree trunk is how you could do this. So you can kind of think, well, the tree trunk, kind of looks like this or something like that, but you could kind of maybe think of it as sort of like a cone, truncated. You could try and like figure out kind of like circles and stack them up on the volume of a short cylinder. But this is kind of a topic we're going to figure out how to do second semester. We're going to actually estimate volumes of three-dimensional objects, weird ones, really weird ones. And tree trunk is kind of like a simple one. But anyways, just something to get your mind thinking. Okay, that's it.